just took a break. We're back. Okay, so the first one, the actual length. A is actual. N is nominal. Like a 2x4 is a nominal. What's the actual dimension of a 2x4? 1.5 by 3.5. Okay? Correction for temperature. If you go to your book, it shows you the correction for temperature. And length corrections. You go to length corrections, slope, where you at temperature correction. And you can look on page 1318 and get the formula. So this is page 1318. There's the formula in your book. 50645, that's the coefficient of expansion for metal. It'll grow 0.0000645 inches per inch per degree Fahrenheit. Coefficient of expansion. If you're a physics buff, it's alpha. Okay, this is the temperature you're using it at in the field. This is the standardized temperature of 68 degrees. Subtract the two, you can see that the sign is a product of the math. If it's over 68, it's going to be a positive number. If it's under 68, it's going to be a negative. Carry the sign with you. Okay? So there gives you the correction for temperature. Okay, then we've got a choice. Is it fully supported? Or is it ends only? These are ors. Okay? This isn't both. Now, these aren't in your book. Okay? So you're going to have to write these down and keep them somewhere so you've got them. Pull. Correction for pull. Pull in the field minus the 10 pounds. That's our standardized right there. 68 came from right there. 10 came from right there. That's the difference in pull versus the 10 pounds. Take this. Multiply by the length of the tape. I use LN. If you want to use LA, use it. It doesn't make any difference. The amount is going to be so small that it's nice to multiply by 100 than it is 99.96, okay? They take that, that's PL over AE. A is the area, cross-sectional area of the tape, and if you took 3360, construction 3360, chapter 2, it's right out of there. It's elongation due to an axial load. So this is, A is the cross-sectional area, and E is a modulus, and we're using the steel tape. That's the modulus elasticity of steel. Back in 3360, you should have had that. Okay, so there's your equation if you're going to have a pull involved. Getting longer or shorter because the pull is not 10 pounds. And then the sag. The sag is going to have a, and I'm going to put this out here all by itself. We have students squaring a negative number and getting a positive number. That's not how this formula is put together. So minus the weight of the tape. The heavier the tape, the more it's going to sag. Okay? 24p squared. Okay, let's see if that makes sense. The heavier the tape, the more it sags. The longer the tape, the more it sags. The harder you pull, the less it sags. So that's a perfect equation, okay? So this is the weight of the tape, the length of one tape, and this is the number of pounds you're pulling it with in the field. The F is field. Same as this guy. Oh, it's not there. Okay, yes, same as that one right there. Okay. Okay, when I get done with this, I'm going to add these. LA prime is the actual length with all of the factors applied. Okay, so you notice I've got this taken care of, I've got this taken care of, and I've got one of those two taken care of. Alignment I haven't addressed yet. I'm going to do that later. Okay, now when I get this, what I've got is I've got the length that I think it is and the length that it actually is. Okay, now how do I deal with that? Okay, I think it's one length and it's not. So I go out and I measure. How do I make the correction to make sure that the number I'm in the field that I'm using is actually the number? Okay, so what I've done, I want to give you an idea. Here's a piece of wood that I've got, and I've made a yardstick out of it. On this side of the stick, I've laid out 1 foot, but 1 foot is 11 inches on this thing. This tape is supposed to read a foot right there. And if I measure it with a corrected tape, it will only measure 11 inches. So I'm going out here, and I've got, I should have bought, I can do this, I think. Okay, there's 2 points. I want to measure between them. And I've laid those 2 points. Actually, let's just do this to start with. Let me go back to here. Let me do this. 1, 2, 3. Okay, in the real world, that is actually 3 foot apart. Okay, if you took an accurate tape measure, you laid it out between this point right here and this point right here would be 3 feet. What I'm trying, this is the mental part I'm talking about in this particular unit. Here's a tape measure. It's marked 1 foot. It's only 11 inches. So I go out in the field and I measure this thing. So I come here and I say, okay, there's 1 foot. I got it written all the way. There's 2 feet. There's 3 feet. With my tape, which is too short, what am I going to record? Aren't I going to record about 3 foot 3 inches for that 3 foot length? Because every foot is 11 inches. It's not really 1 foot. So when I get done, 3 foot's there and I got about 3 inches left over. So if I measured with this stick that's too short, I'm going to end up with a dimension that's too long, right? What if I flip it over? Now I've got one that's 12.5 inches. Okay, I'm going to start there. And I'm going to go. And when I do that, I'm going to end up now with 3 feet being out here. Okay? If I measure it with my 12.5 inch, I'm going to be 1.5 inches too long. What I want you to see is that if the tape's not right, you've got to make a correction. And I'm going to show you, you can mentally go through what I just did on every problem that we've got. I'm going to show you how I use this number and this number to do exactly the same thing and not have to think a whole lot about it. Okay? So, if I measure this with a tape that's too short, instead of having 3 feet between the points, I'm going to have about 3'3". If I measure it with a tape that's too long, instead of having 3 feet between the 2 points, I'm going to have about 2'10½". Okay, so I've got myself a problem. So how do I deal with it? Okay, let me show you. And unfortunately, there's 2 different things we got to worry about. One is layout, the other is measure. You know the difference between the 2. I've got 2 points out in the field that are in the ground. Your project manager says, go out and give me a dimension between those 2 points. That's measuring, right? What if he hands you a tape measure and 2 stakes? He says, go out and put these 2 stakes in the ground and make sure that you have exactly this amount of distance between them. That's layout. So the first one, you take your tape measure, you go between 2 existing points. That's measuring. Second is you take a tape measure and 2 stakes with you. You go out in the field and you put the stakes in the ground yourself. That's layout. So we've got 2 different modes, and they're exactly opposite each other with respect to the tape. Okay? So let's go about it. Here's the simple part now, hopefully. Hopefully you got this down. If you are measuring, now this is the tape length you think it is. This is the tape length that is actually it is after all the corrections are applied. So now we've got measure and layout. Okay, if you already figured those, all we got to do is this. If you're measuring something, you take LA prime over LN and multiply it by the measured value. Okay, in my little case, that line I just had, we have a tape that is actually 11 inches long and it's supposed to be 12 inches long. I think it's a foot. It's actually 11. I'm going to measure in the field 3 feet. So in this case, I would have let's see, actual 11. All I do is take what I think it is, put over what it actually is, multiply by the amount that I'm measuring. That gives me the adjusted measurement. So if you want to do a layout, all you do is flip it. And you can do some mental gymnastics in your head. Hopefully you understand the difference between layout and measure. Measure's there, layout is putting there, and they're exact opposite as far as mental thought process. Okay, once you got now this is going to give me the revised measured distance. And this is going to be the revised layout distance. So if I was doing a document and I wanted to record what it really was, I would use this number. If I was heading to the field and wanted to lay it out properly, I would take this number with me to the field and lay it out to that number to get the exact dimension I want. You're laying out something that's not right, but it is right. The number's not the right number you want, but it gives you, with a corrected tape, it gives you exactly what you want. Okay, that gets rid of that, and then the last thing is alignment. And alignment is simple. If you can do trig, you can do alignment. So let me do a alignment. Okay, we just figured this.